This question is about esters. Figure 4 shows an incomplete mechanism for the reaction of an ester with aqueous sodium hydroxide. Add 3 curly arrows to complete the mechanism. So this is an unfamiliar mechanism. What we're trying to do is look at the difference between each step and try to see how our mechanism has changed to work out what we need to do. Remembering that a curly arrow shows movement of a pair of electrons. So if we have a look, what is happening here on this first curly arrow is we are creating this bond here between the oxygen and the carbon. If we then look for other differences, we can see that this part is staying the same and this part is staying the same, but that there is definitely something changing here because it's going from a double bonded O to an O minus with a lone pair. So that's where we need to make our change. So I'm just going to remove that highlighting from our picture. So we're trying to create a single bond between the C and the O. So we need to break one of these two bonds. We start the arrow at the bond and we're putting the electrons onto oxygen because the oxygen is becoming negatively charged. So that's our first curly arrow. Our second curly arrow, if we have a look between the difference that's happening in step 2 between the second and the third picture, is we can see that this curly arrow that they've drawn on here is recreating the double bond. We can see that this OCH3 seems to have fallen off. It's up here now. And everything else is staying the same. Okay, so if we again remove our highlighting, so we're recreating the double bond with this first curly arrow, we need to lose this OCH3. So we start on the bond that's holding it on and we're going to put the electrons onto oxygen. We can tell that's happening because when it's fallen off over here, it is a minus on the oxygen, so it's gained electrons. So that's our second curly arrow. And then our third curly arrow, if we have a look at the difference between the things at the beginning and end of step 3, we can see that this curly arrow here is picking up this proton to make methanol. That then needs to fall off of our structure, so we need to break this bond by taking a pair of electrons in the bond and putting them onto the oxygen. That gives that oxygen the minus charge. So that's our 3 curly arrows. Name the type of reaction shown in figure 4. So this says type of reaction. This is not the name of a mechanism because we know this is an unfamiliar mechanism. What we're doing here is we're using sodium hydroxide in solution and we're using it to hydrolyze our ester. We're breaking our ester up, breaking the ester bond, and so this is a type of reaction called hydrolysis. Deduce the role of the CH3O- ion in step 3. So we look at step 3. CH3O- is accepting H+. So what does that define? That's the definition of the term Bronsted base. And then it says a triester in vegetable oil reacts with sodium hydroxide in a similar way. When triglycerides react with sodium hydroxide, the product is used for soap. When triglycerides react with methanol, we make biodiesel, but when they react with sodium hydroxide, the sodium salt of a triester is soap. The sodium salt is soap.